And that was one of the reasons why you see that icon on the slide to remind us of this. All right, so everyone, welcome to the special geothermal talks. Before we dive into this, I would like to bring to you and to your attention something really cool happening for the third time. And that will be the SPE Europe Energy Geo Hackathon. We have started a couple of years ago. The new edition is starting at the beginning of October. We'll have 4 weeks of boot camps and 4 weeks of a hackathon challenge. So what did the team think about? We brought geothermal energy, geosciences, and data science together. And how can we keep educating our students, young professionals, senior members in the industry on, just gaining more skills? I invite you to scan this QR code that you see on the left side of your screen. Look into it, check the website out, talk to people around you that are interested in this kind of education and challenge. And also, very importantly, if you're willing to support and your company is willing to support this kind of events, please let us know, get a hold of us. A lot of the things in this industry will not work if we don't have the financial support and the technical support. This is big. There's a lot of sections that have come together in Europe to make it happen. And we're trying as much as we can to push on geothermal energy education, on data science education across all sections. Without further ado, for those that have never been on a special geothermal talk, essentially what this is it is an effort of 10 sections in Europe. We got together and we said, okay, what else can we do? We gotta keep sharing the message of geothermal energy among the energy professionals, because you can't really just be an oil engineer or a gas engineer. You have a diversified skill. And so how do we do that? And we got together. We had monthly sessions since February. Today is the 6th one, and it's really nice. And one thing I wanted to bring up, what I've run into recently is, and there will be a poll shortly, but there's professionals that are strictly in geothermal energy, and there's professionals that are in oil and gas. Essentially, we're all working towards the same goals of giving value and giving quality of life, right, among the world. But it's important to acknowledge, I've recently ran into oil and gas professionals that have kind of slid into the geothermal world and kind of came and said, oh, we're going to do this or we're going to do that. But there is a time for that, because geothermal has been around for so many years. There's people that have been doing this for 20, 30 years that know a lot better what they're working with. So I think it's very important to acknowledge that if you're coming from the oil and gas, and then you collaborate together, because we've learned a lot. We've had a lot of experience drilling deep, hot wells, scaling issues, and everything that comes with it, right? And at the end of the day, we're trying to enhance whatever we're doing, right? So it's very possible that we all work together for this and keep learning from each other. This is the list of the presentations we've had until now. We had started with Dr. Richter from, I think, geoenergy. We talked about low enthalpy geothermal. Then we did upcycling of hydrocarbon wells. So we're looking at how to change things, right? Then we had Mr. Pejman Omrani, who I'm sure is on the call today as well, talk about, the role of operational expenditures in geothermal. Very interesting webinars. And then Mr. Dragutin Dimitrovic, who gave us a really detailed presentation about the geothermal business currently ongoing in Croatia. What's the status? What's the appetite? Next month, we're going to be talking about the geothermal energy situation in Ukraine. We'll have our members from the SP Central Ukraine section talk about certain projects that are ongoing and plans for the future. So that will be very exciting. One thing I wanted to remind you all is to stay hot geothermally. I think it's very important that we keep doing what we're doing and we keep having this support. It's been a tremendous number of registrations for this webinar, and it makes me personally very happy, and our team that has been working together with these special geothermal talks. And hopefully we go beyond the 50% attendance, because we all went into webinar mode, and some of you must have just come from your vacations, so there's that as well. I would like to introduce our speaker today, Sonia Isabella López Kovács. I hope I said that correctly. She's a reservoir engineer advisor at Repsol, Spain. She's been a big supporter in SPE, and if you follow her on LinkedIn, and I'm sure most of you do, she does some very interesting posts that you can check out. She's a petroleum engineer with a master's degree in reservoir management, has an MBA in renewable energies. She's more than 20 years in the oil industry, working in reservoir engineering activities, surveillance, reservoir characterization, and simulation mature fields and green fields. So she's kind of seen it all in terms of that side on the reservoir side, right? She's currently working in the BD projects and technical evaluations of acquisitions and divestment assets. Hence, why interesting, the whole topic of repurposing oil and gas to geothermal. She's been an SP member and communications and outreach chairperson for SP Spain section and AAPG Sustainability Brazil section. So without further ado, what I'm going to do now is I will stop sharing my screen and give the podium to Sonia. Thank you very much for being here today, Sonia.
Thank you, Harry. Let me to share my screen. Okay, you can see my screen?
Yes, it's loading. Yes, if you can put it in full screen mode now.
Yes. Okay.
Perfect. It works. Thank you.
Okay, good. Okay, good morning, good afternoon, everyone. Thanks for attending this webinar. It's a pleasure to be share knowledge and some research and about this hot topic about the repurposing oil and gas to geothermal. Basically, what I shared today is why oil and gas industry are investing more in geothermal energy, then the similarity and difference to oil and gas with geothermal, and why we are moving to geothermal to the oil and gas industry, and of course the repurposing oil and gas wells options to geothermal, to convert to geothermal energy. Okay, let me to move. Okay, as we know, today we have some climate agreement worldwide and some carbon targets in order to reduce the greenhouse gas emission. Renewable energies capacity are and will be increasing, but the oil and gas will continue to have an important part of the global energy mix. We need energy for electricity, heat, cooling, for our necessities today. And based on that, geothermal energy is part of this main contributor and will be contribute with more in the global energy mix. Okay, as we see here in this graph, as we know, we have used energy for electricity, but a amount of this part of this energy we need to use for heat and cooling. In this part of this of power, we can use the geothermal. Geothermal have a main capacity to contribute with heat and cooling. Okay. Okay. Many of us, we know that geothermal energy, it's simply defined as the energy extracted for the earth. Okay. Geothermal energy, it's very important, and we know that it's the energy that always is on, independent of the time and the weather. That it is really important because as we know that wind and solar have a very important renewable energy today, but these energies are intermittent. But in the case to geothermal, it's always on. Always we have the geothermal energy, or we can extract independent to weather conditions, during the hours of the day, and etc. Okay. Then we know that the geothermal energy always it's basically zero emissions production. It's not generate any greenhouse gas emission, or maybe it's less the greenhouse gas emission to generate. Based on that is that we see that today there are a lot of interest in this into develop the geothermal energy. We pass to the follows. Sorry. Okay. As we know, the oil and gas industry are moving to the energy transition, As we know, we lead in order to have the net zero emissions in worldwide. Okay, based on that, there are oil and gas companies that are moving to reduce the greenhouse gas emission. Based on that, we have some commitments and pledge for the oil and gas industry in order to achieve the net zero emission by 2050 or sooner. As we know, basically the majors, the small companies, the EOC, in EOC, and inclusive some startups have this commitment. Also, the oil and gas industry have some pressure in order to be or to become carbon neutral and to implement more and more low carbon technology in order to reduce this greenhouse gas emission. Based on that, that is the important, or there is the interest in order to develop the geothermal energy in the oil and gas industry. Okay. A part of that, the oil and gas industry have some advantage in order to implement the geothermal energy. Why? Because the oil and gas industry have explored and exploit the subsurface, and we know, or the oil and gas industry know very well the subsurface. Then oil and gas industry, we know that there are diversified the portfolio in order to incorporate not only renewable energy like wind and solar, but also including some low carbon technologies like CCS or CCUS, and also hydrogen, green and blue hydrogen, and also the geothermal energy. For some companies, investing in geothermal energy, it's like continue to as business as usual to oil and gas activities, because there are some similarity, but of course there are some difference in order to the fluids and other topics, but there are some knowledge, expertise, and skills that can be used into geothermal energy. And another important point is that oil and gas wells can be repurposed to become or to use for geothermal energy in order to extract electricity and heat. Okay. Also, there are some additional interest or advantage in order to transition the oil and gas industry to geothermal, because if we use, for example, oil and gas wells to convert to geothermal, we can reduce the capital cost. For example, it's not need to drill a new wells. We can use the existing oil and gas wells. Then we can use information to oil and gas or to some oil and gas fields in order to flow rates and some properties like porosity, permeability, temperature, and etc. And we can, based on that, we can estimate or the potential and main candidates wells. The another important advantage is the deferment and about the plug and abandonment cost. That this is a very important parameter to be considered, because the plug and abandonment cost is really huge in some of the fields, and we can extend the lifetime of these existing oil and gas wells. Also, we can use the conversion or repurposing oil and gas wells to use part of this energy to use in our oil and gas operations. And we can substitute the diesel or gas-fired power to replace by geothermal energy. Or includes, we can extract this part of the energy and to provide to near surrounding areas in order to provide this energy. Okay. Of course, sometimes we can escalate to large operation, and as I mentioned before, we can extend the well life of these fields. Here in this graph, we can see that the oil and gas industry have some targets to decarbonize the operation. based on that, the geothermal is an important part of these activities in order to reduce the greenhouse gas emission in this operation. We can use part of this knowledge, skills, and expertise in the geothermal fields or application. And based on that, we can use for inactive, suspended, abandoned, or existing oil and gas well. That this means that we propose oil and gas well. Also, we can co-produce geothermal energy with the existing oil and gas. That means that we can produce in the same time oil and gas, depend of the main fluid, and also geothermal energies. And also we can use the geothermal resources, like for example, for EOR, or also we can extract geothermal energy in a new green field or some aquifer to extract the heat or electricity. Okay, moving into some similarities and differences between the oil and gas and geothermal, we can see in this table, this is some illustrative similarity and differences between the oil and gas that we see here in the table and geothermal. Of course, the main difference is the fluid, because in oil and gas, we have some hydrocarbons, basically oil or gas, and in geothermal, we have the water or steam. In the both, we can use the temperature, but in geothermal, it's important to have not only the subsurface, but the surface temperature. We need to consider permeability. In both, we use permeability because it's a way to the fluid move in the subsurface. But also in geothermal, we use the conductivity. We refer to in place in oil and gas. In the case to geothermal, is the heat in place. In both cases, in oil and gas and geothermal, it's important the flow rates. But in oil and gas, we refer to flow rates in barrels per day or million SCOF per day. But in the case to geothermal, we use kilogram per second or kilojoules per second. It's more or less the same, but with different units. In the flow rates, it's really important in geothermal. In the way that we have more flow rates, we can get more energy, usually. Of course, in oil and gas, we have, or we designed the facility plant, but it's based in barrels per day or million standard cubic per day. In the geothermal, we can use the plant capacity, but this is in kilowatts or megawatts. In both cases, we refer to the rocks or the subsurface, like we use sedimentary rocks or volcanic rocks, depending volcanic rocks. Of course, in geothermal, we have more possibility to have more temperature. We can use also the fracture dominated systems. That is important because we can extract the heat or power with this system to fracture. And in oil and gas, we can use the subsurface temperature, but sometimes it's around 120 or 150 centigrades. But usually in geothermal, we're looking for higher subsurface temperature. Around 150 centigrades is that more used to electricity generation. As I mentioned before, in oil and gas, we have different fluids or oil and gas, basically, and also we produce water, but in geothermal is water and steam. And of course, we use some up rocks or some analogs, but usually in oil and gas, the fluids are static, and in geothermal are in motion. Okay. As I mentioned before, in oil and gas, we can use some workflows where we go work in integrated teams that include geology, geophysics, petrophysics, facilities engineer, drilling engineer, production engineer, reservoir engineer, and etc. that are part of these teamworks. But of course, in geothermal energy, we need to use or integrate all of these different disciplines in order to have a better understanding about the subsurface. And of course, part of this workflow that we usually use in oil and gas, we can apply in geothermal. For example, here we can design the static model, like using geophysics, geologic knowledge, then, and of course, integrate the petrophysics. Then we integrate to reservoir characterization in order to get the fluid flow in porous media. And then we can predict the field performance and estimate how many wells we need to produce geothermal, to produce some producer wells and injector wells, and also integrate with the drilling, completion, and fracturing operation in order to estimate how much geothermal or energy we can extract for these fields, wells, and etc. Okay. Here, this is an example. This is a very interesting spark chart. This is basically some how we can how the skills for reservoir engineer in this case. Here we can see the source for this graph. We can see that the skills for reservoir engineer can be applied to geothermal. In this case, we see in the blue color represent to geothermal reservoir engineer, okay? Then in the orange start or lines correspond to experienced oil and gas reservoir engineer. And in the gray line correspond to the recent petroleum engineer graduate. As you can see, there are some points or parameters that it's similar between the geothermal reservoir engineer and with the oil and gas experience engineer. For example, just understand the thermophysical properties of water, then interpretation of geothermal reservoir pressure and depth with pressure and depth. Also, there are some similarity between fracture, faults, and associated fluid flow, and etc. Of course, there are some difference because geothermal reservoir engineers, they have some knowledge about thermal properties of water and steams, but the difference is not so much in this case, in this point. Also, another is the numerical simulation of geothermal reservoir. We need to consider additional parameter or additional things. This is important, this graph, because this can explain that with some reskill and upskill, and of course, to study some parameters, we can have more understanding about the reservoir and geothermal properties, and to have a better modeling for to this system, and to extract or to identify how much heat and power we can extract. Okay, based on that, we know that geothermal wells, we use or is the way to extract the power and heat from the subsurface. We can see in this graph, this is the geothermal well. Here is the blue one correspond to the injector well, the water injector well, and the red well correspond to the producer well that produce basically hot water from the subsurface. As we know, between the oil and gas, we use the wells. Of course, in geothermal, we need to consider different parameters in order to basically to drilling, because in geothermal system, we have more temperature in the subsurface. Based on that, we need to take in consideration an additional parameter in the drilling process. But of course, for the at the end, it's basically the same process in order to drill geothermal and oil and gas wells. About the completion, it's really similar. Maybe in this geothermal well, we use higher tubing size in order to extract more volumes of water or steam. And of course, another important things is that geothermal wells we can use not only to extract power or high temperature of water, we can use for extract heat for use for to provide heat for example, district heating, greenhouse gas agriculture, or industrial processes. That means that, for example, we can use shallow geothermal wells in order to be extract this heat in the subsurface. Okay. Okay. Based on that, we know that when we have a geothermal or green geothermal area, we need to drill a new geothermal wells. Based on that, this require a high investment capex, and sometimes these capex can be not help in order to continue the project in the next steps. Sometimes, based on that, or this is there are the opportunities to use existing oil and gas wells. Depend of the location or the fields, can be abandoned wells, inactive wells, or sometimes active wells that are producing right now oil and gas. We can use as geothermal to produce geothermal energy. Okay. In the case, for example, to United States, there are a lot of abandonment wells that can be used to repurpose to oil and gas wells. Okay, and this is an opportunity in order to generate energy to provide to heat or to power, depend of the case. Okay. Some of the repurposing options for existing oil and gas wells include, for example, injection for geothermal reservoir support. For example, when we have a geothermal field, usually we need not only the geothermal producer wells, we need also some injection wells in order to have a support for pressure, to maintain the pressure. We can install some exchange systems in the well, like we see here in this graph below. We can install some closed loop retrofill options in the existing wells. We can produce, for example, in a deep aquifer, for example, we can have a gas reservoir and we have an aquifer in deeper. We can produce with another well this water for this deep aquifer and produce or extract the heat water. When we have some oil and gas wells that have high water cut, we can use or to reconvert to geothermal. And of course, in the depleted hydrocarbon zone, we can use to produce or the water to extract the heat. Okay, here in the graph, we can see that there are the co-production with oil and gas. We use some marginal wells to have the co-production, and also this is the geothermal concept that we use some geothermal producer well and the injector well. Okay, basically the two options for repurposing oil and gas well to geothermal are the conversion and the co-production. Which is the difference? The difference between the conversion and the co-production is basically in the conversion is we use some inactive or abandonment wells, and of course we need to have some screening criteria before in order to see which wells are a good candidate or not, and we can convert to geothermal wells. Okay. In the case to co-production, the co-production is that we have some fields or wells that are producing oil and gas, and we can at the same time use to produce steam. We can extract, for example, for these wells, part of the water that they produce, and we can extract the heat for these wells. One of the main candidates to use for co-production or conversion is when we see fields that or wells that have higher water cut, as in this case. This is a good candidate to include as repurpose or convert for geothermal, because this high water cut or high water production that we can use to extract the heat. Okay. In the case to conversion to oil and gas wells to geothermal, is basically to convert the well from producing to producing basically geothermal energy. As we see here, basically there are several options. Is the abandonment, the inactive well, and depend of the condition of the well, the depth, temperature, reservoir conductivity, and etc. We can use one or another well configuration. This will be depend of this characteristic. Of course, sometimes if we see that have a good potential in some deeper aquifer, we can re-drill or to do a sidetrack in existing oil and gas wells and to go to these aquifer zones in order to extract the heat water. Then we can recomplete or implement some or install some borehole head exchanger in these existing wells, or some that sometimes we call closed loop systems, in order to extract this geothermal energy. And of course, there are another option is to drill multilateral slim holes in order to extract this water or heat from the subsurface. In this slide, we see some closed loops well scheme configuration. As we see here, this is a coaxial closed loop geothermal system. We see here, this is in the left side, this is the well, and we can inject the water in the annulus, and then we produce the hot water in the tubing, okay? And we can use a heat exchanger. In this case, we use the subsurface or temperature and the rock conductivity in order to heat this water. Sometimes we can use water or another working fluid. This will be depend. The another possible configuration is the horizontal version of this coaxial closed loop geothermal system. As you see here, we can inject the water or working fluid in the annulus, and then we produce by the tube. Okay, this is called closed loop because this is a closed systems. Okay, and another option is the U-shaped closed loop geothermal systems that we see here. This is the injector wall, and then we have the producer. And in all of these systems, we use a heat exchanger. Okay. Of course, this is a geothermal system concepts that will be depend of the different conditions that we have in the well, in the reservoir, and in the subsurface. Okay, here there are some news or that and some studies or about repurposing oil and gas wells. This is one for Seraphim Energy that this is from the last year that they award a geothermal study on repurposing offshore wells in UK. This is an interesting project that they will try to repurpose offshore geothermal offshore wells. Of course, there are another news, basically in the United States. This is from the last year. In order to the Department of Energy from United States, they awards 8.4 million for geothermal potential for abandoned oil and gas well. As you see it here is the different companies that they get these funds in order to study this option into the United States. Also, we have this about for Baker Hughes that launched a consortium from exploring technologies to transform abandonment wells to geothermal energy production. This is a very interesting project that, of course, this is focused basically in use the abandonment wells in geothermal energy, basically in the United States too. Okay, the another option is the co-production. The co-production is basically when we are producing or we are in mature hydrocarbon fields, and we can basically produce this hydrocarbon, and at the same time we can extract the heat or the power from the water that we produce from these wells or fields. This is there are two in this there are two graph or pictures in the slides. We are the one option is this is the production well. In the left side, we produce basically gas, and then we extract the water, and this water comes from 130 centigrade. With the heat exchanger, we extract the heat from the water, and this water then we use to inject to subsurface using one injector well. The another option is we have the production wells. In this case, we produce gas or oil and gas. We can use the gas for electricity. And of course, we can extract the water that this is coming to 130 centigrade. This is coming from the organic ranking plant in order to extract and then to heat exchanger to extract this heating or power. And we use this water to reinject, that is cool, this water to reinject in the injector wells. Okay, this is the two options that we have in order to use existing oil and gas well to geothermal, to conversion and to co-production. Okay, there are the repurposing oil and gas well to geothermal. This is not new. There are some pilot projects in the past. This is the one that was in 2008 in United States, in Wyoming, that they use some existing wells in order to co-produce hot water in order to generate electricity in an operating oil field. Okay, this is one of the case. Of course, there are another in 2011 in China that they use the geothermal power. This was basically to low temperature geothermal power plant in order to use to basically to co-produce oil and use the water to produce heat. There are another case in 2016 that this is in North Dakota, in United States, that they co-produce electricity from geothermal resource and from the oil and gas well. Yeah. And of course, there are another more cases, as we see here in this table, not only United States or China, there are some in Albania, in Hungary, in China, and also in, or basically in China, okay? The most recently is this project that is in Canada, that the idea is to co-produce, basically this project is in Alberta, they produce gas, natural gas, and the idea is to co-produce geothermal with the existing oil and gas field. This is very recently, this is from 2000, well, this news is from 2023. Additionally, there are different case studies, as we see here in this table. You can see in more detail. This is from the SP paper. You can see that there are different case studies worldwide in order to see about the potential for geothermal energy using existing oil and gas wells. As you see here, they are in Australia, in China, Croatia, Indonesia, Italy, Malaysia, Trinidad and Tobago, and etc. Of course, this is basically the interest that there are today in looking for options for oil and gas to use geothermal. This case, in this slide, we see, for example, this is the map of UK, and they have identified the geothermal, the deep geothermal place, and also the geothermal sites. They have identified the hydrocarbon fields with potential for geothermal repurposing. You can see here in these red cycles, this corresponds to geothermal hydrocarbon fields with option to repurposing to geothermal. You see, there are identifying this map. This is opportunities in UK. Okay, moving to the main option, or what we require for repurposing oil and gas well to geothermal, it's important to consider three main things. That this is the potential targets, that is, of course, the location, if there are some local regulation, the data available. We need some reservoir data like pressure, temperature, fluid composition, water geochemistry, fluid flows, well characteristics like well configuration, age, drilling, completion, tubing size, casing size, the trajectory, logs available, and the cement condition. The cement condition is really important too. Then also we need historical production, because the pressure and production, it's give us some indicative about the potential to how much heat or power we can extract for this well. The feasibility is referred to the well integrity, if there are some well barriers, about the casing or cement condition. Heat generation, about the subsurface temperature and surface temperature. Fluid flow and fluid selection, because depend of the wells that we have will be depend of which tubing we will use. And some risk analysis we need to study additional, we need to study some additional risk. Okay, in this table, you can see this is a workflow that we propose, and this is published in, I present in the EAG Energy Transition last year. That this is refer about, this is the workflow that or the screening criteria that need to consider for the existing oil and gas well to compare to geothermal. Basically, you need to consider depth, temperature, location, geological settings, reservoir, wells, and surface. About the depth, of course, if we have deep hydrocarbon wells, it's better because there will be hot. If we have more than 70 centigrade, it's better in order to get more heat in this well. About the location, it's better when we are onshore than offshore, because this energy we can use, we know we can use. There are more options to use in onshore than offshore. The geological settings depend of if we have some sedimentary systems, we can have some hydrothermal reservoirs. In the case to hot rock, maybe we can have some carbonatic, that maybe we can fracture these rocks in order to get more communication and improve the permeability. Of course, the porosity and permeability is really important, and also the thermal conductivity. Thermal conductivity we need to consider when we evaluate these repurposing oil and gas wells. About the reservoirs, we need to know the historical fluid production, oil, water, and also gas, but it's better to have if the well have produced oil and water. Well productivity, the well productivity gives us an idea about the potential for these wells. And of course, the reservoir pressure, because the reservoir pressure gives us also the potential for these reconversion, these repurposing wells. About the wells, we need to know basically the integrity or the status of these wells, which condition have these wells, because not all the wells have the condition to repurpose or to convert to geothermal. If they are vertical, deviated, or horizontal, of course, it's better vertical compared with the horizontal. The casing diameter, if the casing diameter is higher, it's better compared with the small casing diameter. And of course, one condition is we need to have a good cement bond, not have any corrosion or breaks, etc. Additional important things that need to consider in the surface is the facilities, because the geothermal energy, we need to connect to some utilities, or if we need to have some road access, the pad size, and etc. We need to have some requirement, because this is important that there are some requirement about to use this heat or power in order to provide these to the surrounding areas. Okay, moving to the available data from the oil and gas that we can use to geothermal. Basically, when we refer to geothermal or to geological settings, our reservoir properties, as I mentioned before, porosity and permeability, connectivity, it's important. If in the way that we are deeper, usually the permeability are low, and this is not a good condition when we refer to repurposing oil and gas well, because maybe we need sometimes with to fracture or to improve the permeability in these wells. Then temperature. The temperature is really important when we consider the geothermal, the oil and gas wells to compare to geothermal. Not only the subsurface temperature, but also the surface temperature, because this difference in temperature is that we can use in order to estimate the power and heat generation. In the ways that we are deeper, of course, is hotter, and this is best. This is what we are looking for. Okay. Then rock thermal conductivity values is important because this gives us about this we include in our estimation or calculation for heat generation. Then we need to use some logs or existing logs for existing oil and gas wells. It's important the resistivity, gamma ray, density, and of course cement log. The well completion data about the complete zone, perforated intervals, casing diameters, and completion histories. And all the information related to these wells. Of course, about the performance and production data. The production data give us about the potential for these wells that can be, when we convert to geothermal, give us how much heat or power we can extract. Okay, in the way that we have high flow rates, it's better, or it's good to consider for a potential candidate from convert to geothermal. we can use the decline curve analysis as we use usually in oil and gas in order to estimate the remaining reserve and decline for the existing wells, in order to estimate how much resource we can obtain from not only from the oil and gas well, inclusive from the geothermal wells. This, in this case, in this picture, part of this decline or estimation of remaining reserve give us about the potential for geothermal potential. In this slide, this is from this paper. It's referred to wells that have potential to can be repurposed. This is basically in the United States. And we see here that red dotted points correspond to the wells that have higher flow rates and high temperature. Based on that, these wells have potential or are candidates to repurpose to geothermal energy. Another important point that when we refer or evaluate a potential candidate to geothermal energy, it's we need to identify the near areas that we can, or the infrastructure in order to this energy that we can extract, where we can connect. Here is based to the same study that in the previous slide, we can see the red lines correspond to the existing energy infrastructure, and this is the potential wells candidate to use to geothermal. This is an important thing in not only for reconvert or repurposing oil and gas well to geothermal, inclusive to green geothermal fields, that we need to consider the existing energy infrastructure in order to connect or to deliver this energy to these areas. Okay. As much of us, we know that the geothermal energy have a lot of potential uses. We can use the geothermal energy not only to produce electricity, we can produce to heating, to cooling, district heating, to co-produce oil with heat, as I mentioned before. We can use for agriculture, aquaculture, for animal regeneration, for CO2 separation process, for grid electricity, and etc. Also, one of important potential uses, and we can use the existing oil and gas wells to geothermal, is for mineral extractions. This mineral extraction basically mean, in this case, for lithium and maybe another minerals, but lithium is have high focus right now. We can use part of this brine that we can produce with the water, and we can extract from the brine the lithium, and we can use this lithium for another important usage that we need today. Okay. Of course, about repurposing oil and gas well to geothermal, there are some challenges. Basically, it's about the geothermal, the well selection. Basically, it need to have a good geothermal gradient, proximity to end users, how much geothermal production, if heat, power, and how which energy we can use. Of course, another important challenge is the data availability, because not always, independent that we have some oil and gas, existing oil and gas wells, not always we have all the data availability. About the technical side is the well integrity, that is really important, and management for only residual hydrocarbon production. And another important point is if there are any regulation or environment concern. This is really important because sometimes if we need to take in an attention this regulation on environment in order to give it be aligned with all of this. Okay. Okay, and in order to have some remark or some final comments, we know that the existing oil and gas wells can offer a source to geothermal energy that we can use not only for power, but also for heating and inclusive for cooling. That this is really important today. Then we have the not only to conversion, but we can co-production into geothermal energy with the oil and gas industry. That it's an important way in order to the oil and gas industry go to the carbon neutral and reduce the greenhouse gas emission. And of course, today there are more and more research about the new technology advancements, and of course can be improve the technology to get more efficient and extract more. When we use this kind of well configuration, basically in the closed loop system, we can obtain more efficiency about the heat extraction in the existing oil and gas well. That this is really important, and we see that there are more and more focus from the oil and gas wells and different oil and gas industry and startups and companies and etc. to focus in geothermal. Okay, this is all from my side. Thank you very much for attending.
Thank you very much, Sonia. Thank you so much for the very detailed presentation and kind of showing us the potential of making these changes, right? I can tell you that there's been a lot of questions in the chat box. We will try to tackle those. I will also mention that I see people raising hands. Unfortunately, we don't have much time left, so we're gonna try to tackle some of the questions. Before we move to that, though, there is one thing I wanted to do here, and I wanted to ask you. I'm launching a poll here just to kind of understand a little bit, you know, the demography of the audience today here. Like, have you heard of any projects in your surroundings, you know, that have tried to repurpose oil and gas to geothermal application? So while we are getting the votes in, Sonia, there was a first question that came in from Francisco, and he said, what if we use co-production instead of converting, because converting is risky, costly, and unsustainable? And I think you talked about that, right? You talked about the importance of co-production.
It's important, yes, because for example, at the end, some of the water that we produce from oil and gas fields or wells, it's there are some wells that produce a lot of water, and instead we can extract part of this heat and we can use. This is the main use for that. One example is, for example, in Ecuador. In Ecuador, there are some fields that produce a lot of water. Maybe one well produces 20,000 barrels per day and 90% of water. And there can be potential to extract this heat, and then we can reinject this water.
Reduce it, absolutely. Especially because we have some oil and gas wells that are pretty good depths with good bottom hole temperatures that can be, of course, it requires a lot of planning. So what the audience says here is 64% have heard of some kind of project that's thinking of repurposing, and 36% no, which is actually quite a high number. So that is good news. The second question is from Diogo, and it says, are onshore reservoirs the main target for geothermal?
For the moment, yes, because of course, offshore can be an option or potential, but which is the problem? At the end, when you cannot be a storage so easily the heat when you extract. That is the problem. In the case to offshore, maybe you can use the heat, but in the platform to use for electricity or heat, not to develop to the grid. You know, that is the problem.
So the storage is the challenge, right? Because of the distances as well and the process itself.
Yes. Yeah.
Okay. We have a question from our friend here from SP Central Ukraine that says, any cases of Repsol geothermal project worldwide for whatever you can share? I mean,
Repsol, they are looking for some projects about geothermal, but not for the moment. I cannot share any case.
Understood. No, that's fine. That's fine. Thank you. There is a question here from Vanessa that says, what about the high temperature for cement and metallurgy? I suppose she meant the
For the well, I suppose. No?
Yeah, yeah.
It's a challenge. That is the reason that we need to take in consideration in the screening side when we evaluate the existing oil and gas well, all of these parameters like cement, temperature, well configuration, if there are any potential leakage, etc. Yes.
Understood. So well integrity itself as well,
Yes.
right?
And sometimes we can put some insulation into the well, if possible, but it depends. It's not so that you say, no, it's a rule that you can apply for all the existing oil and gas well. No, you need to study each well because each well have some challenge. Maybe one well can be used to repurpose because have the potential for depth, but not for temperature, or maybe have problems about the casing or potential about the production, because maybe you have all the condition about the subsurface, like temperature, and have a good condition in the well, but the potential about production, that is not good. And there is not a good candidate from compared to geothermal energy.
Okay, so basically what you're saying, it's important is to have a very detailed workflow in terms of finding candidates and understanding how, well integrity matters and what the production numbers look like and what is the extraction look like and how that economically makes sense, because we still live in a world that works on economics, right? And I think that is one of the biggest challenges now, is a lot of the governments are giving incentives in terms of pushing some of the projects forward, but we as energy professionals should be working on finding ways to do it better and cheaper, optimize that way, it's much easier to roll out these projects. There's one question, it's an interesting one from Diogo that says, do you require a water treatment plant for the closed loop systems to treat the water?
Yes, of course, need to be considered. Yeah, this is part of the evaluation, but at this point, that what I present is not include more complex things, no? But yeah.
Yeah, I understand. That's a little more in detail, and that's not good news for the CapEx, but it is what it is. So Rodolfo Torres says, what is the progress, and if you know anything about this, of the regulations in Europe to convert the oil wells into geothermal wells?
Really, I don't know. I know that in France, there are some projects that in order to convert existing oil and gas well to geothermal, but about the regulation, no. I think there's
been quite some pushes on the last chat we had with the creation section, and there was a little more description on that. There's been dynamics. It's very important that you put the right people in place to make these regulations.
Yeah,
I think that is crucial. I think that's one of the challenges, based on some of the experience I've had as well, in why certain countries struggle with rolling out certain technologies, because it's not the people that understand the process that make the calls, and we need to change that. Okay, so we have a question here from Adeline that asks, and that's kind of a difficult one, I would say. She asks, what is the average CapEx to repurpose oil and gas wells into geothermal system?
No, I don't know.
It's a tough one.
It will be the pen of the case. No, I don't know.
Yeah.
Because if you have a deeper well, it's one CapEx, and if you have a shallow well, it's another CapEx, and maybe, no, I don't know.
Gotcha. Okay, there is a question that came from Carlos Lobo that says, regards Sonia, excellent presentation. In your opinion, what is the main challenge or barrier to unlock the geothermal development in Spain, the Canary Islands and continental area? Feel free to answer or not answer this question, but yeah.
What is the challenge?
Yeah, the main barrier to unlock this possibility. Nice place to go and have geothermal wells.
In Spain, it's really, I suppose it's basically for electricity. There are some challenge, but to go in details, I don't have these details in order to share right now. No.
Okay, maybe what we can do.
there are some projects in Spain, not only for Repsol, for another companies, to looking for geothermal potential and extraction, geothermal extraction to heating. For that, there are a lot of projects right now.
Understood.
But for electricity, there are more challenge because we can have some volcanic island, yes, in Spain. But the problem is, where do you locate the power plant? Maybe you need to locate near to the population, and this is a risk. Not a risk, but maybe it's a problem with
the local communities.
yes, or maybe you don't have time, or the people don't want. I don't know. This is some comments.
No, that's a very valid point. So one thing we've learned that in the US, there's a very good communication with the local communities and educating them about what the project is about, how it works, what the footprint is, what it does, what are the risks. And I think one of the main points to take away is transparency, because, you know, transparency will help get the support for these projects to roll out, exactly what you're doing, what it will mean for the community. But Canary Islands sounds like a nice place to have a job at.
No, and I attend a webinar that the speaker is from Mexico, and there are some challenge about the community because there are some community that is not agree with the geothermal extraction.
That would be interesting to see. Maybe we can talk later what the webinar was. I'm interested to see what is it that bothers, you know, that is the main problems about it. But anyways, there's one more question from Branimir Cvetkovic. It says, can you comment a little bit on the geothermal reservoir simulations to simulate fluid flow and heat transfer behavior in the subsurface?
Okay, it's about to talk about the geothermal simulation, is the question?
Yeah, a little bit of like on fluid dynamics, right? Fluid flow and heat transfer in a specific geothermal case. Like, how do you do it? Are you using similar softwares like oil and gas? Do you have to get help from?
For the moment, I don't use any geothermal simulation for the moment. Any geothermal study. But yes, you can use as there are some specific software for from Schlumberger. I think to the Navigator 2 to CMG, all this commercial software can be used to simulate the geothermal. Of course, you need to consider not only the subsurface temperature, but you need to consider the rock conductivity. Rock conductivity is important in order to include the convection and conduction, process.
Dynamics, the mechanics of it,
that can be occurring in the subsurface. That is important.
Absolutely, yeah. There's one question that's interesting. It would be good to know about this. It says, is there any open source screening criteria list available for repurposing oil and gas abandoned onshore wells? Oh, that's a good one, but I'm not sure. What do you think? Is there? Yeah, for like an open source one, like basically, if you know, access a website, put in the data, and it tells you, hey, you can repurpose it. It's a good business idea.
No, this is good. And to generate, estimate the potential, not the
I think so, yeah.
No.
All right, there's 50 people on this call. Whoever comes up with this, please split it equally between 50 people. Yeah. All right, so we had one more from Francisco Porturas, and he said, are we using too often oil and gas industry goggles, I suppose, for geothermal? Have you found some disadvantages? Oh, this is difficult. I don't know what he meant by, it says googles, but I'm not sure that was the word. Okay. Francisco, if you can clarify in the chat box, we can come back to this question. There's another question from Carlos, from Pedro Arias says, do you know any experience using geothermal energy to support the petrochemical processes?
No.
You do not know. Okay.
No, for the moment, no.
Understood.
Maybe there are, but my understanding or my research or looking for, not.
Okay. We have a good comment here from, I hope I said the name correctly, Ragad El Sayed. She says, Eclipse Thermal or Intersect can both handle most of the simulation physics for geothermal reservoirs. There you go. So if you guys are looking for that,
Yeah, for sure. But one important thing that need to include not only in an intersect or eclipse in CMG or all the commercial software is the rock conductivity.
Mhm.
That is
And-
important.
And have you found in your experience that that's been a difficulty in a sense that the databases don't really have that data for conductivity values, or?
I don't know, Gabriel.
Okay, yeah, no problem. We can look into this. Okay, so Francisco cleared it. He said Google, he meant goggles for safety glasses. So if I go back to his question, that's an interesting question. So are we? Okay, so are we too often using oil and gas safety goggles for geothermal? I think it's figurative, right? Have you found some this? I'm not sure, Francisco, I got that one. Please clarify in the chat box. Carlos asked, what do you think of combining the production of geothermal energy with the production of other economic activities like Bitcoin mining or green hydrogen production?
You can combine geothermal energy with Bitcoin. I don't know. This is not but with hydrogen production, you can combine, of course. You can have some hybridization with the different renewable energy in order to get the better and to get more energy, of course. Because, for example, you can use geothermal with wind farms or solar farms too, or biomass, and etc. Yes, but
that
I don't know.
But that requires one thing that we generally are bad at, humans, it's communication and working with others much better than we did in the past. I think that's one thing we need to do better. That's why at the beginning of the webinar, we were talking how important is that oil and gas and geothermal talk to each other, which begs the question real quick here. There's a poll I'm going to launch. It's very interesting to understand a little bit of our audience here. Who in this audience is an SPE member or not, and it's not a matter of just being oil or gas or not, but just to understand what is the demographic. I'm getting the answers in, and we see it's very nice. It's a mix half. So I'm expecting that the other half join SPE, and then the SPE ones join the other geothermal societies. So if I end the poll and I share the results, you have 57% that are SPE members and 43% that are not. I think we have one more question here that we can tackle right now, Sonia, if that's okay with you.
Yeah.
It says, when we talk about target temperature of 150 for electricity generation, is that reservoir temperature or geothermal fluid temperature at surface?
It's reservoir pressure, usually.
Yeah, reservoir temperature, okay. So you're talking about the reservoir temperature, because then on surface, that value will certainly be lower.
Yeah.
Understood. Okay. One thing I would like to mention here, first of all, I'd like to thank everyone. Please don't jump out of the meeting. Second of all, Sonia, thank you so much for putting your time aside. I know it is vacation times and everybody needs a break, but taking the time to do this really means a lot. I hope the audience enjoyed the talk. There is a link that Jawad posted in the chat box. It's the SPE Hackathon link. Click it, take 5 minutes, learn about what we're doing, because it's really interesting. And we're always looking for support, and anybody that's ready to learn some Python, learn about seismic, learn about geothermal energy, just register there. It's coming up in the next 2 months. One last thing to mention is next month we'll come back with our 7th talk, and we'll have our SPE Central Ukraine present on the topic. What I will do, Sonia, if that's okay with you, like we talked, is you share the slides in PDF format, and I will send the slides and the recording to everyone, to all their registrants, so that they have access to it. That's okay with you?
Yeah, no problem.
Thank you so much, Sonia. Thank you, everybody, for being here today, and we'll see you on the next SPE Geothermal talk. Bye.
Bye.